So today's lesson is Chapter 5, Lesson 6, which is the coordinate plane. Okay? In the warm-up, it says identify the ordered pair that names each point, then identify the quadrant in which it is located. So this should be a little bit of a review where you guys used all of the positive. You would use this first quadrant before, right? Now this part is new for some of you. So we want to identify point A. So point A is right there. We want to name the ordered pair and name which quadrant it's in. So we always start at the origin and we go to the left. 1, 2, 3, 4, 5. And then we go up 1, 2, 3. So because we went to the left, what kind of numbers are over here? Negatives. So that's going to be a -5. What kind of numbers are up here? Positives. So that's going to be a -5, comma, +3. Is everybody clear with that? -5, +3. And then the quadrant it's in, that is quadrant 2. Okay? This is quadrant 2. Now let me just tell you, the quadrants here. This is the first one. This is the one that you guys started with. This is quadrant 1. And when you write your quadrants, you write them in Roman numerals. Okay? So that's quadrant 1. Then over here, this is quadrant 2. And then over here, this is quadrant 3. And then finally, quadrant 4. Let's take a look at point B. Point B is right there. Okay, so what is the ordered pair for point B? We're going to go to the left. 1, 2, 3. We went to the left 3 and we went up 1, 2, 3, 4, 5. So that's going to be -3, comma 5. Oops, -3, comma 5. And that is also in quadrant 2. Okay? How about point C? You guys have that one done already? Okay, what's that going to be? -1, 2, 3, 4, 5. So that's -5, comma, down 2. That's -2. -5, comma, -2. And that's quadrant 3. Point D, over here, there's point D. We went to the right and then down. So tell me what that one is. Positive 1, 2, 3, 4, 5, and down 3, which is -3. So it's +5, comma, -3. 5, comma, -3, and that's quadrant 4. See that? And then point E, right here, we're going to the right 2 and down 1, 2, 3, 4, 5. So the ordered pair will be 2, comma, -5. Very good. And it's in quadrant 4. Very good. So on the coordinate plane, you guys, these are just number lines, right? So here, this is a number line. This is a horizontal number line. What kind of numbers are over here? Positives. What kind over here? Negatives. And then this is a vertical number line where what kind of numbers we have up here? Positive. And then down here we have negatives. Very good. So that is what's going to help you when you are graphing and identifying points on the coordinate grid. Is everybody clear? All right. So now we're going to identify points and ordered pairs. So make sure you write down your heading. Definition. So here, a coordinate plane is formed when the x-axis and the y-axis intersect at their 0 points. That is what a coordinate plane is. A coordinate plane is formed when the x-axis and the y-axis intersect at their 0 points. The axes is plural for axis, the axes separate the coordinate plane into 4 regions. So the 4 regions are called the quadrants. Okay? And we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, just like we said in the warm-up. Okay? Now, you guys started learning graphing with quadrant 1, right? With only the positives, right? So that's where you started with. That is your first quadrant, okay? And then think about this. The coordinate plane starts with a C, right? Coordinate plane starts with a C. So if you go from the quadrant 1 to quadrant 4, does everybody see this? So quadrant 1, then quadrant 2 over here, quadrant 3, and we write them as Roman numerals. Quadrant 3 and quadrant 4. Is everybody clear? Now, we just talked about what kind of numbers you have over here in quadrant 1. We have positives and positives. Does everybody see that? We've got positive, comma, positive right here. You should sketch this graph in your notes. We have positive, comma, positive here. Now, in quadrant 2, what kind of numbers do we have? We go to the left and then we go up, right? So that's going to be what kind of numbers here? Negatives and positives. So over here, it's going to be negative, comma, positive. Okay, this is something that will help you decide which quadrant you're in, what kind of signs you have on the ordered pairs. Quadrant 3 down here, what kind of numbers do we have on there? What kind of signs do we have on there? Negative, comma, negative. Very good. So this is a negative, comma, negative. And then in quadrant 4, what kind of numbers are those? Positive, comma, negative. Very good. This is positive, comma, negative. So here we want to identify the ordered pair that names point C. Then identify the quadrant in which it is located. So here's point C. There's point C. And when we identify that, the first thing we're going to do is we're going to start at the origin. We're going to start at the origin, and then we're going to move right. Okay? Start at the origin, and then move right. So from the origin, we move right. Now, to get to C, we're going to move up. Does everybody see that? So then we're going to move up. So to get to C, we're going to go to the right and then up. So to identify this point, we're going to look at the movement to the right. So that's 1/2, 1, 1.5. And then we're going to move up the y-axis. That's 1/2, comma, 1. So here, this is going to be 1.5, comma, 1. Is everybody clear with that? So for example 2, when we identify the point located at -1 and 1/2, comma, -1. Then we want to also identify the quadrant it's located in. Okay? So if I'm looking at a -1, 1.5, comma, -1, we're going to go to, which way are we going to move this first one? Starting at the origin, we start at the origin, and then we're going to move to the left. Okay? And then we move to the left, and then we're going to move to the -1. Which direction? -1. We're going to move down. Okay? So we're going to move left and then down. So what quadrant is that? This is quadrant 3. Is everybody clear with that? That's quadrant 3. Because we're moving from the origin. See if we have our ordered pair, right? If we're going to move from the origin. Alright, so we will move from the origin. We're going to move to -1.5. So that's going to go to the left. And then we're going to move down to -1. So down here is quadrant 3. All right, so for these got it problems, we are going to use the example 1, the coordinate plane for example 1. We want to identify the ordered pair that names point A, then identify the quadrant in which it is located. Okay, so here's point A, there's point A, and we want to know how did we get to it. Okay, and remember, when we are working with ordered pairs, an ordered pair is x comma y. X comma y. An ordered pair is x comma y. And we are trying to find A. So we're going to start at the origin. Does everybody see this? Can you see the yellow dot? So we're going to start at the origin, and we're going to move which way, left or right? To the left. So we're going to move to the left, 1, 2, and then we're going to move up, 1, 2, 3. Now, if we were counting by ones, that would be negative 2 comma 3, right? But we're not counting by ones. What are we counting by? Halves. So here, this is going to be 1/2, negative 1/2, and negative 1. Negative 2 halves is 1, right? So that's going to be negative 1, comma 1/2, 1, and then 1 1/2. So at A, we have negative 1, comma 1 and 1/2. Now what quadrant is that in? Don't forget. Right, that is quadrant 2. And we're going to write that as an ordered pair. I mean, as a Roman numeral, sorry. So problem B is asking us to identify the point that is located at 1 comma negative 2. What is the point that is located at 1 comma negative 2? Well, let's see. We're going to go to 1, which is positive, so we're going to go to the right 1. Okay, so there's the 1. You see it? There's 1. And then we're going negative 2. So we're going to go down negative 2. So there's negative 1, and there's negative 2. So this is point E. Very good. This is point E. And what quadrant is that in? 4. That is quadrant 4. And we write that as a Roman numeral 4. This is the part where it's going to get a little, just a teeny tiny bit more challenging, okay? So make sure you write down your heading. We're looking at reflections on the coordinate plane. Reflections on the coordinate plane. Make sure you write down your heading. Now here it says you can use what you know about number lines and opposites to compare locations on the coordinate plane. Consider the number line and the coordinate plane below. The number line shows that negative 4, and 4 are opposites. The coordinate plane shows that the points negative 4 comma 0 and 4 comma 0 are the same distance from the y-axis in opposite directions. So if we look at the coordinate plane, see it looks just like this number line up here, right? Negative 4 is over here, positive 4 is over there. Looks just like this number line. What this is saying is that because they are the same distance from the y-axis in opposite directions, they are reflected across the y-axis. Okay? And we also want to notice that the y-coordinates did not change and the x-coordinates are the opposites. So if you look here, there's the x-coordinates, negative 4, comma 4. I mean negative 4 here and positive 4 over there. In this example, we are reflecting across the y-axis. So go with me. Which axis is the y-axis? The up and down or the left and right? the up and down. The up and down is the y-axis. So here, let's say we have our y-axis. This is just going to be my y-axis right over here. If I have a point over here and I want to reflect it over the y-axis, whoops, this, which way is that point moving? Is that moving left to right or up and down? Left to right. It's moving left to right. Okay, is everybody with me? If that point is moving left to right, what axis shows the left to right movement? The x-axis shows the left to right movement. Is everybody with me? So, when we are reflecting over the y-axis, because we're moving left to right, you with me? The x value changes to the opposite because it's a left and right movement. So, what do you think will happen if I want to move this point and reflect it over the x-axis? If I want to reflect over the x-axis, which way is my point moving? Up and down or left and right? It's moving up and down. Which axis shows me up and down movement? The y-axis shows you the up and down movement. So that tells me that which coordinate is going to change in my ordered pair? The y value. Is everybody clear with that? So let's take a look at this example down here. Okay? Here, let's just bring this picture down. So here it says, name the ordered pair that is a reflection of -3, 2 across the x-axis. So here, if I'm reflecting over the x-axis, once again, the y value is what's changing. Is everybody with me? So if the y value changes to the opposite, then what's my new coordinate going to be? -3, -2. So here we want to name the ordered pair that is a reflection of each point across the x-axis. Now remember, if I'm moving across the x-axis, which value changes to the opposite? The y value changes to the opposite. So here, this one is the y value. Remember, it's x, y, right? Don't forget, this is x, y. So the y value is changing to the opposite. So each one of those is changing to the opposite of what's there. So, for example C, what's my new ordered pair? 1, the opposite of -4 is +4. That's my new ordered pair. How about D? -2, -5. Remember, it changes to the opposite, right? And then over here, this one's going to be -3, +1. Is everybody clear? All right. All right, for the last example, it says Kendall is building a square fence. She places fence posts at the locations indicated in the grid. What is the location of the post that reflects -4, +4? So here is -4, +4, and we want to see what is the location of the post that reflects -4, 4 across the y-axis. So here, if I'm if I'm reflecting across the y-axis like this, that means, see, the movement is left and right. That tells me that the x value is going to change. Okay? So the x value, remember it's x, y, is -4. X is -4. So that is going to change to the opposite. So the opposite of -4 is +4. So the post over here is going to be at +4, +4. So 4, 4. So for the got it, Kendall also placed a fence post at -4, -4. So negative 4 comma negative 4 is right there. We want to know what is the location of the post that reflects negative 4 comma negative 4 over the y-axis. So once again, we are reflecting over the y-axis. And again, when we are reflecting over the y-axis, the x value changes because that shows the left and right movement. So with negative 4 comma negative 4, the x value changes. So the opposite of negative 4 is positive 4. So the new fence post will be at 4 comma negative 4. And 4 comma negative 4 is right there.